So find the coordinates and nature of any turning points. Remember, these are also sometimes called stationary points, because if we have an inflection point where our slope is still 0, but we don't actually turn the direction. So turning points and stationary points will have these same procedures. So the first thing we're going to do is we're going to find the coordinates of these turning points. Now, turning points happen when our graph has a slope of 0. So in order to find when our graph has a slope of 0, we need to find our derivative. So we're going to use our power and sum rule. So dy dx equals 3x squared plus 30x plus 63. Now, because we want our slope to be 0, it means we want to solve for when this equals 0. So we're going to go 0 equals 3x squared plus 30x plus 63. First thing to notice in this is all of these things are divisible by 3. So we're going to take everything in this equation and divide it by 3 so that we have smaller numbers to deal with when we're solving. So 0 divided by 3 is 0 equals x squared plus 10x plus 21. So now we could solve using the quadratic formula, but I'm going to solve this by factoring. So when we factor, I need two numbers that add together to equal 10, and those same two numbers to add together to equal 21. So in this case, that is going to be 7 and 3. So because there's no coefficient in front, we can go right to our factored form. X plus 7 and x plus 3. So when we're actually solving for our x values, we're going to set this equal to 0. So that means x would equal negative 7. We're going to set this to 0. So that would mean x would equal negative 3. The problem is it wants the coordinates of the turning points. Well, this isn't a coordinate because we don't have the other value. We don't have the y value. So right now I have negative 7 and something, and I have negative 3 and something, but I don't know what these y's are yet. In order to figure out what these y's are, we need to put the x into our equation and solve for the y that goes with it. To solve for the first one, you're going to go y equals negative 7 cubed plus 15 negative 7 squared plus 63 times negative 7 plus 7. So when we do this, we get an answer of negative 42. So the y value that goes with this one is negative 42. The y value of the other one, now we're going to put negative 3 in for all of our x's to find the y value that goes with it. So negative 3 cubed plus 15 negative 3 squared plus 63 times negative 3 plus 7. And this one would give us an answer of negative 74. So now we've determined the coordinates, negative 7, negative 42, and negative 3, negative 47. But now we have to determine the nature. So the nature means, is it a max? Is it a min? Or that other one that we have sometimes, which is the inflection point. So the way to figure out if we're max, min, or inflection, we need to know what happens before and after these values. So we're going to do our first derivative test. I like to set it up using a number line. I'm just going to try to keep everything on the screen here. So I'm going to draw my number line, and I'm going to put in my x values. So I have negative 7, and I have negative 3. So now we're going to put test values into our slope to see what was happening before I got to this turning point. Was I increasing or was I decreasing? So we can choose any number that's less than negative 7 to see what was happening on this side of our graph. I don't know, let's go negative 10. And we're going to put that into our derivative. So we're going to go 3 negative 10 squared plus 30 negative 10 plus 63. Really, we don't care what the number is. The only thing we care is it positive or negative? Because that will tell us were we increasing or decreasing before this value happened. So this is going to give us negative 10 squared. It's going to give us 100, so that's going to be 300 minus 300 plus 63. So we're going to get a positive guy on this side. So that means on this side of 7, I was increasing to this point. So now we have to see what was happening on the other side. So again, we need to pick a test point. This time, my test point has to be between negative 7 and negative 3. So I don't know, let's go negative 5. And again, we're just going to put negative 5 into our derivative function and see if we end up with a positive or negative value. So we're going to put in negative 5, and we find out that on this side, we get a negative value. So that means in this section of my graph is now decreasing. So that tells me that I was increasing, switched to decreasing. So at this point here, we have a local maximum. So we still have one more thing that we have to see. We have to see what happens after this turning point. Do I start increasing again? Do I keep decreasing? So we need a new test point. A really nice test point to use, of course, is 0. Because when I put 0 in here, that's gone, and we're just left with a positive 63. So this side we are positive. So that means we go back to increasing on this side of the point. So I was decreasing, now I'm increasing, meaning that the nature of this point is a local minimum. And there you go, that's your first derivative test. Finding your critical values, finding the coordinates, and then determining the nature of those coordinates.